working with the timer for our catcher game, there is a timing function that we're able to access the milliseconds of at what point did the program start running. The computer puts it essentially starts a stopwatch. Then we can say how many milliseconds have you been running. So we're able to take advantage of that or capitalize that to use that to create a stopwatch or timer. And once we can create a timer, we can set the interval in which we want it to run. Do we want it to fire off ticks every 1 second, 5 seconds, 10 seconds? Whatever we choose is part of that process, and then we can put that into it. So the timer, as we're going to work with it, it's going to be a class. So we're going to work on that, and it's a timer. Now inside this timer, we're going to have a couple of values we work with. We're going to have a start time, and we are going to, because we will want to know what is the time, because with the timer what it will do is it will run, and once it's done running, we'll say, hey, start again. So we need to now know what is that time, because the computer just has its clock running continually. That's kind of the issue that we're running into on that, and we'll kind of see how this works in a moment. And then we're going to set up an interval. The interval is at what point do we want the timer to register out and say, hey, I'm done. So with this, we can create our stopwatch and say, I want it to run every second. So we'll tell it, hey, I want you to run every 1,000 milliseconds or 1 second. And then we'll keep asking it 60 times a second. We'll say, hey, are you done yet? And if it says, yep, I'm done, then we can tell it to reset itself and start again. So there isn't a built-in kind of whole complex timer class that's already part of processing. So this is why we have to construct our own to make this happen. Now we use our class constructor statement. And we're going to be passing to it a value. And we'll see how that works, where we will set that interval is equal to that time. So when in my main game, I'll say, hey, I want a timer, and I want the timer to run every 1,000 milliseconds, or 1 second, because there's 1,000 milliseconds in 1 second. So I want my timer to fire off based on seconds. So with that, we're going to pass it a value of 1,000, and we'll say then our interval is based on that. Now, if we knew that every timer we ever wanted to make was based on 1 second intervals, we wouldn't need to pass that in. We could just say interval is equal to 1,000 and just be done with it. But it makes more sense to build a timer class that's a little bit more flexible, because on some projects we may want a half-second interval, or we may want a 2-second interval. So we have that ability to work with different values on it. Now our timer is going to have 2 methods as part of it. One will be start, and the other method is not going to be void, it will be a Boolean. And we're going to ask our timer, are you done? And we do that by, we will give it a method of is finished. So we will keep asking the timer, are you finished yet? Are you finished yet? Are you finished yet? 60 times per second, our frame rate. And then when that Boolean returns back a positive value where it says, oh, yeah, I'm done, then we're able to recognize that and make something happen. Now, inside well, we have to figure out the start one first. This is where we set start time, our other class variable. We set it equal to the current time in milliseconds that the program has been running. So the statement millis asks your program, it says, how long have you been running? And it gives you an answer back in milliseconds, or thousandths of a second. It tells you how long it's been running. So it may give you back an answer of, 5,384. Or, I mean, it'll just give you whatever number based on how many seconds the program is running. So that's why we say, okay, now set our start time equal to that, because we'll tell a timer, hey, start. And now we're going to create another value that we're making a value. It's not a permanent value. It's one that we just are going to be working with here inside our timer. And that's our elapsed time. And now we say, well, what is now the current time? And we subtract from it the start time. So every time we ask our program, millis, it says, this is how many milliseconds the program's been running. So when we call out timer start and tell our timer to start, it sets start time equal to whatever the current time is. Then when I will call is finished, I'll say, hey, are you done yet? And it's going to figure out, well, how long have I been running? And it does that by saying my elapsed time is equal to what the now current time is. The current time is, and it tells you, and then we subtract from it the start time. So unless start and is finished happened simultaneously, which would be impossible because things are happening sequentially, separated by however many thousands of seconds, this elapsed time is always going to be some type of positive value. It could be 1 if it was really, really fast, but that's unlikely. It's usually going to be a bigger number. Now if we say if elapsed time is greater than our interval, which is how long we want our timer to run, we're going to return a value. Now if you remember when we talked about functions, most of our functions don't return a value, they all start with void. When our function returns a Boolean, our code is going to have to return something. And it's in this case it's going to return either true or false. So it can only give us back one of two items, true or false. And this is all the timer class needs. At this point, we now have a timer class that we can use as is for the remainder of the semester. We don't have to do anything to this, and we can use it in every project we need a timer for the rest of the term and beyond if you want. I mean, you could write additional methods to it and finesse it more, but this is enough to get going. This gives us a timer. If I want to add the timer into my main thing, I'll say timer to reference the timer class, and then I can say timer, well, just call it a timer. Now, I guess my main project probably needs some base values put in so we can do something with it. But now if I say timer is equal to new timer, remembering that I'm referencing the class with the capital T, that fits with timer is defined with the capital T. Again, things are case sensitive. So timer is equal to a new timer. And my timer class is looking for an interval. It's looking for what kind of interval do I want it to run on. In this case, I'm just going to put in 1,000 to represent I want my timer to click out every second. So 1,000. Now, what we can do is at that point I can just say timer start. So I can call the start method of the timer. So timer has a start method. So we're able to call it. The same way that when we have our visual objects where we can call their update method or their display method and all these different parts that are of the class that we did last week, or last 2 weeks, or last night, depending on when you worked on it. Today, depending on when you worked on it. But we can call the method. This is part of that class, so we can now call that. Tell the timer to start. Now it's not really going to do anything unless we make something show up on screen here. So now we need to make something show up on screen as part of this. So as part of adding this in, we're going to do a count up versus a count down timer, but or we could do a countdown timer. And we'll count up. I'm going to start first with that method. So I'm going to have a value, I'll just call it current time. And we'll start with it has a value of 0 here. Now clearing the background, we will want to clear it, because if I don't do that, then each time my timer runs, I'll get the numbers that will be displaying on screen momentarily are going to sit on top of each other, and that's going to look really junky. So we don't want to do that. So now what we can do is display some text on screen and say text current time, and then we'll put it at 100, 100. So what's happening is clearing the background, putting some text on screen, looking at it. Right, so current time is going to start out at 0. We're going to set the fill color to black, put some text on screen where we'll put the word time plus then current time. Now if we run the program and take a look at it, we can see that it comes up and says time 0. For aesthetics, I just like to have the colon there. It just makes it look a little bit better, I think, where you see the colon and now we see the time. Now, just to see what we can do with current time. Currently, current time it's set to 0 and there's nothing that makes it go up. But if I were to say current time plus equal 1, so let's just add to it. Let's just see how that looks. When we look at our project, we'll see that you can see how it's going up approximately 60 times per second. So we can see, but that's not that's based on frame rate, that's not based on the timer. But it shows us how we can modify current time or work with that. But what we really want to have happen is we want to say if timer is finished is equal to true. Now if we remember in the timer, it has its isFinished method, and that returns a Boolean. So it either returns true or it returns false. So if the timer is finished, I want the current time to go up by 1. Oh, wrong. Delete there. There we go. So if the timer is finished, we want current time to go up by 1. So what we should see happen now is instead of going up 60 times per second, it's instead going to go up 1 time, go up 1 each second. And now it's based on the timer. Now if I run it, if current time is finished, it goes up. But what we did not do, so after 1 second it starts running, but what's not happening is current time is not resetting. Or I mean, the timer is not resetting. And this is part of the using the timer object. So timer goes up, but then what we have to do is go timer. We tell the timer to restart at the end of it. 2. So what happens is each time the timer is finished, then when we tell it to start, the timer is no longer finished anymore. It only is finished every second, and then we're able to create this timer that goes up. So some of you may decide that you want your catcher game to have a timer as part of it because it's going to count. It's going to be either a count up or count down timer. You give the player 60 seconds to catch as many things as they can catch. Or you give the player 30 seconds to catch. So you do count up or count down depending on how you want to do it. Right now this is a count up timer. But we could turn this into a count down timer as well. So if I want it to count down, I start my current time. I'm going to start it at 10, and then I'll say current time minus instead of plus 1. So now when I run it, that simple change meant my timer now, instead of going up, is going down. The only hitch here is once I hit 0, it's going to keep going down. So if we want it to stop at a certain number, then we would have to put the logic in for dealing with that. And we would have to figure that out as well. So then we could put in if it's done. And if we want, when it hits 0, we want something to happen, then we would need to listen for that. But otherwise, we could just say if current time, where if we added to this and said current time is greater than 0. Because if the current time is greater than 0, then we can subtract 1. But if the current time is 0, then it's not going to run anymore. 8, 7. And what you'll find is if you use timers and you do like 30 seconds or 60 seconds or whatever you do, you will probably want to, while you're testing your game, not do the full amount. I mean, in this case, even waiting 10 seconds was painfully long. So then you just shrink that number to a smaller one to begin with, and then you just change it in your final production model of your game. But now it's stopped at 0. Then we could say, put a line here and say, if, now this isn't going to be written in actual code, but if the timer is equal to 0, then game over. And we'll have to figure out how to write that in actual code and what we want that to be. So right now that's kind of like pseudocode of writing out the logic of what we want. So if the timer is 0, then game over. And we have to figure out what that means. But that's later. That's not tonight. We don't care about that right now. But this now means we now have a countdown timer showing up in our game. Or you could leave yours as a count up timer. It doesn't really matter. And that's all before we added in all the other cool, or will add all the other cool stuff into your project. Working with the catcher is going to have a radius associated with it. All of our objects are going to be utilizing what will be called circle-based collision methods or intersections. So our catcher is a circle. The raindrops in the beginning will be circles. So that means they have a center point, and then they have a radius that describes their position in space. And then we can find out, are these two circles overlapping? If so, intersection has occurred. So circle 1, circle 2. When the distance between the centers of those circles versus the size of the circles, the radius, intersect, collision, boom. Fireworks go off, explosions happen, worlds end. It's traumatic. Maybe not that dramatic, but who knows. All right. So with my catcher, we have it set up so that we can, when we construct the catcher, we pass it a value and say, how big do I want you to be? So we'll say your radius is equal to that temp r. The same way that when we made the timer, we passed to the timer kind of a time, we're passing to the catcher a radius value. We're going to start the catcher in the center of the screen. And so we set the x equal to the width, half of the width, and the y equal to half of the height. So we just take width divided by 2, height divided by 2. That's our x and our y. So that now gives our catcher a place to live in the world. So when we add it to the game, it's going to be there. Now, the position for the catcher. So figuring out where it is on screen, it's just going to be based on wherever the mouse is. So the catcher is, in effect, in some ways, we're changing the cursor from being the normal arrow to whatever shape, or in this case, just circle that we're using to describe the catcher. So we can just say x is equal to, well, not minus equal to mouse x, y is equal to mouse y. So this now, whenever we say catcher update, it's going to set its x and y equal to whatever the x and y of the mouse are. So I'm just going to set a few visual. So we'll give it stroke of 0, fill. We can choose a color for it. So if we want our catcher to be colored, so if I wanted it to be something like red, I could go 25500, so it'd be filled with red. Makes it easy to see in the beginning. And we're going to just make it an ellipse. And then we're going to set its height and width equal to the radius times 2. Remember, radius is in essence half of the circle shape. So right now our catcher is just a circle. If I wanted this to be more shapes or objects, I could draw additional shapes than objects here. I could fill them with different colors. I could give them different positions. So if I wanted my catcher to have eyes or something, I could add that in here as well. We'll do that in a minute. Won't do that just yet. But once you have this working, you just update this display function or method with whatever kind of visual code you want, and then you get a new object showing up on screen. But for now, it's enough to get us started. So we already have the catcher variable typed in your stubbed out code. We just need to give it a value. So if I say catcher is equal to a new catcher, and now it's expecting us to give it a radius, a pixel measurement in size. So if I want my catcher to be 100 pixels around, or wide and tall, I would give it then a radius value of 50, because it's going to be then double that. So that now gives me a new catcher. That's simple enough. In my draw, tell the catcher to update and tell my catcher to display. So all of the visual objects that we're going to be working with, so we have the catcher variable, we instantiate it, catcher is equal to new catcher, give it so that we give it its width value, and then we now tell the catcher to update and display. Each loop with the draw 60 times per second updates its position based on the mouse's x and y, and then it draws it at its new updated place. So the catcher has been added to our game. We had the catcher variable when you started. We made our new one. We tell it to update and display, so we call its two methods. Now what we need to do is we need to add in the drops. We need to get the drops going in the game so that we can start working with those. Now when we look at the drops are kind of empty right now. We have a bunch of variables that we will be populating with it, and then we will have update and display, and those are the only two we're going to worry about tonight. We're not going to worry about what happens when a drop gets caught. We're not going to worry about resetting a drop. If we can get all of our drops falling, but also then falling in a sequential manner, so we don't get the hailstorm where it's just a big downpour of all 100, 500, or however many drops we have happen at once, then we're going to be in good shape with that, and that's what we're working towards now. So with that, looking at our drop, we need to put a few values in here. So to start out with, we need to start figuring out x, y, r, speed y, and c. So we're going to work with those values. So if we start out, well, we're going to give the drops a radius here so we can figure out what that radius is on it. And And we need to figure out where are they going to be. So in this game, the drops are falling. We're creating kind of rain. The example in the book is it's the raindrops. We're catching raindrops. So it makes sense that they're randomly distributed across the width of our screen. So our x is going to be based on some random value based on the width of the screen. This works pretty well, except it's possible to have drops that are hanging halfway off the edges of the screen. So to that end, we can always kind of shorten our kind of range that we're working with here, so we could make them show up within a narrower span if we wanted, but we'll use this for now because it's a decent starting point. Now our y value, what would be nice is to have our drops start somewhere off screen, so they don't show up on screen. That's what we're going to go to, but in the beginning we're going to start out with the drops on screen so that we can see that they exist. Because if we start with them, say, above the screen, above 0, so at a negative number, and then they fall down, that's great, except then we don't even know if they're there until they fall into the screen. So we're going to start out with them on screen first, and then we'll go and modify this and give it a negative number so they're starting somewhere off screen. So with this, I'm going to start them out at 10. Eventually, we will move into a value where we're going to use some negative number so they're high enough off screen that then they get to fall into our view. And then we need to set speed y equal to something. And if they all fall at the same speed, it's really boring. It just looks like crap. So we set a random value in. If we say 1, that guarantees they're falling. Some could fall very slow. And then we can say a range, they could also fall very fast. Remembering this is 60 times per second, so that means every second they're going to fall somewhere between 1 every second they'll either fall 60 or 300 pixels per second. So some could be really, really fast, and some are going to be super, super pokey on it. So we'll just roll with it. But that's a decent amount to begin with. So that's taking care of x, y, r, speed y, o, and now we need to figure out a color. What's nice on our drops is if we give them a random range of colors. So we set up and figure out what that color value is going to be. So we say C is equal to color, and now we specify the color that we're looking for here. Now, if we wanted it to be various versions of blue, we could kind of figure out within our color mixer how to work out different variations of blue. And you could pull up your color tool to figure that out. So inside processing, under tools, we have color selector. And under our color selector, we can see where if we look at the RGB values. So let's say I choose a blue color. And we can see now if I'm choosing something where, okay, that's a blue color. So 50, 90, and now 170. Now, if I change this value here and maybe go to 55, we can see it goes to that blue. If I go to this, it goes to that blue. So we can see that by changing the blue value, we're getting kind of a different component as part of it. So we start to figure out as you click around what are some ranges. So perhaps I want my red value to be anywhere from 30 to 50, my green value to be between 80 and 100, my blue value maybe between 100 and 255. So we can work out these different values and figure out kind of color ranges and go, okay, that's what I can work with. So now I can say random, and now if I do something like 30 to 50 for my red, and then do for my green, I might do a random of say 70 to 100, and for my blue, or do a random value of 100 to 255. So I have greatest variability on blue, red, and green are a little more fixed. Now you can decide what color ranges and how you want to do it, but what this means is each drop or circle that I'm going to work with is going to be a slightly different version of blue. And if I don't like the colors that it gives me, I go and tweak these numbers until I get colors I do like. And that's all you have to do with that. So that takes care of all of my initial variables that are part of my drop class. Now we need to modify update and display, because again, tonight we're not going to worry about cut and reset. We're saving those for next week. But under update, this is where we're going to update our position and go y plus equal y, or speed y. So that now updates our y position based on our speed y. And this is great until we've now fallen off the screen. Now if we want, we could make this kind of like asteroids, where when something falls off the bottom, it goes back to the top, and we create that looping effect, which kind of works well on the drops, because then if I just have, say, 100 drops, it can, once they're all falling, it can look like there's thousands of drops, because you don't realize that they're ending and doing things like that. So now we can figure out that if I run off the screen, so if my y is greater than height plus my radius, because if I just say y is greater than height, that means the circle will be halfway off the screen, and it's like, oh, I hit the bottom, because remember, circles register from their center, or registration point, so we have to add in a value. So once I have gone completely off screen, and you can even make that bigger, so you could even go height plus r times 5, 10, or something that guarantees it's fallen way down before it loops back to the top, so you don't see that immediate I hit the bottom, boom, I'm already dropping back in from the top. So if you provide some buffer in there, visually you don't realize it's the same drop looping. But right now we're just going to keep it simple and leave it like that so we can actually see what's going on. But if we do that, I'm going to set y equal to 0. Eventually we will want this to be a negative number, but at least this way now it won't disappear off screen, but it will be half on when it starts refalling again. So now we update based on speed y. If we've gone off screen, we put ourselves back to the top, and then we get to just keep looping and looping and looping and looping. Now, figuring out display is we have to set the color. I like turning off my stroke. You don't have to. I just don't like the stroke on it, so I always turn it off. It bugs me. And then we just draw our ellipse at x, x, y, r times 2, r times 2. And now that draws my drop. So that gives us the drop class. We'll figure out how to use cut and reset in the next class session, but at least now we have a drop. The drop, when it hits the bottom of the screen, will know it's hit the bottom of the screen and it will reset itself. Other drops don't have to worry about what other drops are doing. Each drop is just going to care, has it hit the bottom. It doesn't care what its neighbors are doing. It only cares about itself. They're very selfish that way. So before I add in a whole array of drops and work with a whole array of drops, actually I changed my mind. I'm going to add in a whole array of drops, and I'm going to fill that array with 1, and we're just going to have 1 drop fall. Because once we can add 1, we can add 100, we can add 1,000, we can add 10,000. Any more than that, the thing should probably go belly up, so we don't want to go more than that. So right now I have my array of drops, kind of that variable created. So it's time to populate it. So I say drops is equal to new drop. And this is where now we're going to say drops. Now, for those of you paying attention, you will realize that I've created a variable. Now I'm trying to access a variable, but the variable doesn't actually have any value yet. I never defined how many drops are falling, so we will need to do that on the line prior, because I should have and forgot. So num drops, I'm just going to set it equal to 1 for now. I just want 1 drop. So I have 1 drop, and I'm going to put 1 drop in there right now. We could do 10, I could do 100, but I just want 1 to fall on screen first. And once I know 1 is not crashing it, I'll add a 0 in there or 2 zeros in there, and then we'll see the magic really start to happen. So I need to now populate this array. Populating my array is something that is easiest done using a for loop. And the reason we use the array is because if we had to make drop 1, drop 2, drop 3, and actually keep track of those names, we'd go insane. And writing the code to deal with that would drive us insane. That's why we use the array, and we use our for loop to either fill the array with content or to access the content that is in the array. So we end up using this for loop where we say int I is equal to 0, I is less than my number of drops, and then I plus plus. So we end up using this particular loop as we're going to go through it. I mean, copy paste it, because we use it so many times. I mean, we use that when we're trying to update and display them, we're trying to do intersects, so you'll realize that because we reuse it over and over and over, that just using copy paste can be an easy way to get through it. Because if you want to retype it, go nuts, but I don't. So I've now populated my array with a new drop. In this case, I've put 1 whole drop into it. Once that's occurred, then what we need to do is in our draw function, we need to cycle through that array of drops until each one of those drops, which in this case there are 1, but we're going to tell it to update and display. And again, this is where we can use our for loop for int I equals 0. And again, it truly is the same 1. And if your fingers are getting tired of typing, that's where you decide to use some copy pasting as part of it. And then we can just say drops, brackets I, dot update. And drops, square bracket I dot display, like that. And you have to use drops, not drips. Typos will kill you every time when you're coding. Just recognize, we all make typos when we code, especially when you get tired. You really should take breaks regularly when you're trying to type code, because if you do it for long windows of time, you will find that you start making more and more mistakes as you go. So if you were typing exactly what I typed and said int equals 0, yeah, it's int I equals 0. I hope most of you caught that, but it's been a long day and typos happen. Now, if we look at it, we'll see now the drop is falling. Blue drop is falling. No intersection occurs. And we can see that it keeps falling, and it keeps falling, and it keeps falling. So that gave me 1 drop. That's cool. And as I said, once I prove 1 works, I'm going to add in a couple zeros, run it again. And we'll see that all 100 drops started falling. But they all started falling at the same time, and that's kind of crappy. That's the one thing that we do want to try and address tonight and work with it. But once they are all falling, it looks kind of cool. It's like, ooh, that's kind of neat. So for this final stretch, what we need to do is we need to have a couple more things that we're working with. We're going to have another timer, and this is going to be our drops timer. And then we're going to need to keep track of our active drops. So if you notice, it's much like our timer, and then it had current time where that was an integer and it's able to count with it. Our active drops is going to then be how many drops are currently active or alive in our particular game. So we have those two values that we're working with. So we need to now give them value. Our drops timer will be equal to a new timer. And in this case, we're going to start out and say something like 300 milliseconds. So about a third of a second, one more drop will start falling. So like 3 drops per second will start falling into our game. So after, if you sit there for a little while, pretty soon you have tons of drops. But in the beginning, it'll be 1, then 2, then 3, then 4, 5, 6, 7, until it goes on. Now our active drops will start out at 0. So we start that out at 0. So our drops timer is a timer that will fire off every 300 milliseconds. Our active drops is going to start out at 0. Now the next kind of, it's not tricky as we're going to work with it, but it is going to require us to kind of keep track of things a little bit, is we need to figure out how to make active drops kind of increase and work with that. But we don't want active drops to become too big, otherwise we'll get an error message, because then we will try to be using things beyond the number of items that are actually in our array. So I'm just going to get code a little bit higher on screen here. So what we can do with this is we can say if the drops timer is finished, because it's a timer, so it has access to that is finished thing, so we can even just write it out. If that's true, then we want to make active drops go up. But we don't want it to get too big, so we can say if active drops is less than my number of drops, we can tell active drops to go up by 1. And then we can tell the drops timer to start over. Oh yeah. We'll probably need to tell the drops timer to start up here as well. Otherwise, it's never going to go, and we'll run it and we'll be like, there's no drops, and we'll cry and it'll be sad, and then you'll start cursing me and your computer and programming, and it's all kinds of unhappiness, and we don't want to go there. So back up in the setup, we'll want to say drops timer dot start. So we need to tell it to start. So if the drops timer is finished, and if active drops is less than my number of drops, then we tell active drops to get 1 bigger, and we tell our drops timer to start going again. Now if I run this, absolutely nothing is going to change, because currently we are using and telling all of our drops to update and display. So all the drops are put into that array in the beginning, because remembering the discussion about creating objects is an expensive operation. It takes a lot of computing power. Using objects once they're created and in memory is no big deal. But creating them and destroying them, those are expensive and big activities. So those are things we want to do as little as possible. Once we've made things, we want to keep reusing what we have. So we make all of our drops so they're all ready to go, waiting for us to call them into action. We're going to say, go. And the way that we can change it is say, well, now I only want to, I only want to update and display. So we can say if the drops timer is finished, and if active drops is less than my number of drops, then we tell active drops to go up by 1. And then we can tell active drops to get 1 bigger, and we can tell our drops timer to start over. So if the drops timer is finished, and if active drops is less than my number of drops, then we tell active drops to go up by 1. And then we can tell active drops to get 1 bigger, and we can tell our drops timer to start over. So if the drops timer is finished, and if active drops is less than my number of drops, then we tell active drops to go up by 1. And then we can tell active drops to get 1 bigger, and we can tell our drops timer to start over. So if the drops timer is finished, and if active drops is less than my number of drops, then we tell active drops to go up by 1. And then we can tell active drops to get 1 bigger, and we can tell our drops timer to start over. So if the drops timer is finished, and if active drops is less than my number of drops, then we tell active drops to go update and display drafts that are currently active.